Question number 4, equation solving. It is pretty simple. You just have to cross things over. So first I'm going to isolate the base e of 3 minus 3x, which means that I'm going to cross over the addition of 6 and then the multiplication of 3. You can eventually use your calculator. You start with 33. The addition of 6 becomes the subtraction of 6. And then you divide by 3, and you will have 9. Then you cross over the base e, natural base. It becomes natural logarithm. And finally, to fully isolate x, I'm going to first cross over that addition. Is going to become a subtraction and divide the whole thing by -3. I'm happy with you leaving that like this. For b, it's a little more complex because on both sides of the equation, you have the variable which is inside the exponential. So the trick here, either you can very well apply, which is very frequent, the same logarithm on both sides, and you can also just cross over one of the base. So if I cross over one of the base, x plus 1 drops down, and on the other side I'll have the inverse of base 2 is log 2 of 3 exponent negative 2x plus 7. And then I'm going to use logarithm properties to expand out this exponent, which will become a multiplier, a coefficient. Once you've done that, this is actually a linear equation. Just understand, I'm begging you, that log 2 of 3 is a chunk that you cannot separate. So how do I solve linear equation? First, I distribute. So let me distribute this log 2 of 3 with each of the terms of the sum. So I would have negative 2 log 2 of 3x plus 7 log 2 of 3. See once again how log 2 of 3, I'm just treating it as if it were a regular number. The second step of a linear equation, I'm going to put on the same side all the x's, and all the rest will remain on the right side. That means that the subtraction of 2 log 2 of 3 will become an addition onto the other side. And this addition of 1 onto the other side is going to become a subtraction. You can eventually make sure that you understand, I'm going to factor out the x here. So that's some basic pre-algebra skills. I'm factoring out the x. I will be left with 1x here, and on the other side, 2 log 2 of 3. This side doesn't change for now. And finally, to have x all by itself, I'm going to make that multiplier a divider onto the other side. So this whole right side is going to be divided by this factor of x. 1 plus 2 log 2 of 3. There are ways to simplify that expression into only one logarithm, but I will spare you the difficulty. You can stay like this. C, I cannot simplify logarithm like this. The only way that this logarithm 9, this log 9, will disappear is if it takes the whole side of each side, which means that on the left side, I'm going to condense in this subtraction. So I'll have log 9 of x plus 6 divided by x. Now I can cancel out the logs. And if I solve this and have x plus 6 equals 2x, which means that x would be equal to 6. So that would eventually be my answer, but you always have to verify this with the domain of validity of the original equation. This is why normally you should have this first step given that anything inside the logarithm x plus 6 and x needs to be greater than 0, which means that x needs to be greater than -6 and greater than 0, which is the case here, so you're good. D, let's do the same principle. So, given that x minus 3 is greater than 0 and x minus 5 is greater than 0, which means that x needs to be greater than 3 and greater than 5, given that, I have ln of x minus 3 times x minus 5 equals ln of 3, which means that now that I've condensed that addition into a multiplication, both logarithms cancel. Let me already distribute this. FOIL, I'll have x squared plus 15 here, and -3 minus 5 is -8, so I have -8x equals 3. Let me put everything on the same side. I'll have x squared minus 8x plus 12. And then I need to solve that. So the first thing you should try is to see if you would not have two numbers that multiply as positive 12 and add up to negative 8. You can do that on a scratch paper using, for instance, the visual way of factoring. You're going to put 1 times 12, which is 12, and negative 8 here. You have two fraction bars, and those two numbers are actually existing. It's negative 2 and negative 6. And you put ax, so here it's 1x, both top and bottom, and you'll end up with a factoring form of this quadratic expression, x minus 2 and x minus 6, which means that x equals either 2 or 6. But I need the result to be greater than 3 and greater than 5. So greater than 5, basically, which is true only of this one. X equals 2 is called an extraneous. Therefore, x equals 6. This one is not a solution.